Hello and welcome to session number 8 of my lecture on bending members. In this session, we're going to do an example, and this example difference to the other example is that we do have negative moment too. Example 4. In this example, we want to see if this member is enough for the negative moment or need a bearing is required. This section is W53 times 82, and as you can see, this is the bending moment diagram. And in the example, it said the top flange is laterally supported. So if the top flange is laterally supported, we only care about this space and this space for lateral torsional buckling, because top flange is laterally supported and it won't buckle, but the bottom flange, which is in compression in these two areas, it will buckle, and we need to check the buckling to see if the negative moment needs a bearing or not. In order to find section properties, you can look the tables on your handbook, page 642. Find all the section properties. Then we're going to find the class of the section as we do for all of the examples. Okay, first component we want to find the class is flange. B over T, which will be 209 over 2 over 13.3 will be 7.9. So if I say B over T is equal to X over square root of Fy, X will be equal to 147.8. Now, at this point, X is between 145 and 170. So, flange is class 2. Now we're going for the web. H over W, 528 minus 2 times 13.3 over 9.5, it will be 52.8, which H over W will be X over square root of Fy. X will be equal to 987.8, and as you see, H over W, which is equal to 987.8 over square root of Fy, is lower than 1100 over square root of Fy. So web is class 1. And we know that if we have flange class 2 and web class 1, the section will be class 1. So section is class 1. Next step is to calculate the moment resistance. First, we need to find MP, the plastic. Plastic moment is equal to Z times Fy, which is 70 times 10 to the power of 3 times 350, which is our yielding stress, and over 10 to the power of 6, so we want to make it kilonewton times meter. The result will be 724.5 kilonewton times meter. Now we need to calculate elastic lateral torsional buckling moment. Mu is omega 2 pi over L square root of E Iy G J plus I E over L squared I Y over C W. Omega 2 for this section, because if you look at, let's see the bending moment diagram again, the moment was like this. This is 540 kilonewton times meter, and this is 0. So the ratio of the smaller moment to the maximum moment will be 0. Therefore, kappa is 0. So omega 2 is equal to 1.75 plus 105 kappa plus 0.3 kappa squared, and should be lower than 2.5. So therefore, because kappa is 0, omega 2 will be 1.75. Now if we calculate the mu, it will be 2928.5 kilonewton times meter. Now we have to check to see if mu is bigger than 0.67 MP or is lower than or equal than. Okay. Mu is 2928.5 kilonewton times meter, and 0.67 MP is equal to 485.4 kilonewton times meter. So it is obvious that mu is bigger. So the resistance moment is calculated using this formula: 1.15 phi times MP 1 minus 0.28 MP over mu lower or equal to phi MP. Okay, so our resistance moment is calculated here for you is 697.9 kilonewton times meter. It should be lower than 652.1 kilonewton times meter. And as you can see, the resistance moment we got here in the left hand side is bigger than right hand side, so the right hand side will be the resistance moment. So mr is equal to 652.1 kilonewton times meter. And because it is bigger than 540 we had in the bending moment diagram, no bearing required. Thank you for listening to this session. If you have any question, you can either comment or email me.